Hey tubers, it's Popboys live from Starbase 1. Today we're turning our attention towards Jupiter. Its two strange auroras are apparently pulsing to their own X-ray beats. Yes, scientists have detected a powerful X-ray aurora hotspot near Jupiter's south pole, and it does not behave how they expected. Rather than pulsing in sync with the northern aurora, the southern hotspot runs to its own regular pattern. The south has this really strange regular pulsation every 11 minutes, said William Dunn, an astronomer at University College London and lead author of the study published in Nature Astronomy. This behavior, he explained, is different to auroras on Earth, where the northern and southern lights are both irregular and generally mirror each other. If you think of the spots as these twin features, then maybe you expect them to be identical and behaving in time with each other, and they're not doing that at all. The discovery adds to the mystery of how Jupiter's powerful auroras are created, a puzzle scientists hope will be solved by NASA's JUNO spacecraft currently orbiting the planet. Jupiter's auroras are not like other planets, claim NASA scientists. Jupiter has the most powerful auroras in the solar system, but they are very different to those on other planets such as Earth, claims astronomer Lucina Kedziora-Chudze of the University of New South Wales. She is quoted saying Jupiter's aurora is one of a kind in our solar system due to the strength of its magnetic field and the size of its magnetosphere. On Earth, they claim an aurora is created when the solar wind, a stream of charged particles from the sun, rains down on the planet's magnetic field. The lines of that field direct the particles to the poles where they collide with gas atoms and emit light. But while Earth's auroras only appear during solar storms, Jupiter's are permanent. These powerful displays are generated by high-energy particles in the atmosphere of Jupiter and its moons interacting with the planet's own magnetic field. So these particles are accelerated in magnetic fields and slammed onto the high atmospheric layers in the polar regions of the planet. Again quoted the Dr. Kedziora-Chudze, who also studies Jupiter but was not involved with the research. One question puzzling scientists is whether and to what degree the solar wind also plays a role in powering Jupiter's auroras. In 2000, astronomers discovered an aurora hotspot spewing out X-rays at the planet's north pole, and recent research by Dr. Dunn and colleagues found brightening of the hotspot during a solar storm, which suggested the solar wind was indeed involved. But auroras at the planet's south pole are much harder to see from Earth. So to find the southern aurora hotspot, Dr. Dunn and his international team analyzed data collected by two X-ray space telescopes on two separate occasions, 10 years apart, once in 2007 and recently in 2016. On these days, not only was Jupiter's south pole tilted towards the two observatories orbiting Earth, but the northern hotspot was also visible. The team then compared the activity of the southern and northern hotspots, both of which covering an area greater than the surface of the Earth, so they claim. While the southern aurora gave off pulses like clockwork, pulses from the northern spot were less predictable. Sometimes it pulses at 45 minutes, whereas sometimes it pulses at 12 minutes, and sometimes it pulses erratically, claims Dr. Dunn. The researchers also saw the intensity of the two auroras increase and decrease at different times. Dr. Dunn said the regular pulse his team detected at the South Pole may be caused by the solar wind hitting a specific part of the planet's magnetic field, causing it to vibrate and send waves towards the South Pole every 11 minutes. The charged particles can then surf these waves and collide with the atmosphere of the planet to produce the bright X-ray aurora. It's weird because the aurora are like the signature of the magnetic field. Whatever's happening on a magnetic field line should trigger things that happen in both poles. So Dr. Dunn said it's possible that because we don't get as good a view of the southern hemisphere from Earth, we may only be seeing some of the lines that are vibrating. However, he said there is mounting evidence from other observations that show the two auroras are acting independently of each other. So the JUNO spacecraft may solve Aurora's mystery. Dr. Dunn said the next step in solving the mystery of Jupiter's auroras was to compare polar observations taken by the X-ray observatories with ultraviolet and infrared data from NASA's JUNO spacecraft, which is flying directly over the poles every 53 days, so they claim. JUNO is tasked with measuring Jupiter's magnetosphere for the first time. JUNO is essentially rewriting much of what we had previously thought we knew about the planet, just as these X-ray observations contradict what we thought we knew about the aurora, said Dr. Dunn. Dr. Kedziora Chara agreed that local effects in Jupiter's magnetosphere could cause the aurora to behave independently, but said more observations were needed to confirm these results. Jupiter is a great plasma laboratory which allows us to observe interactions of energetic particles with the strong magnetic fields on large scales. The doctor explained further. Observations of auroral emissions in all wavelengths, together with measurements of particle fluxes in situ by spacecraft like JUNO, will give us a complete picture of these interactions. So, I don't know, give me a comment on what you guys think about these Jupiter auroras, and also what you think possibly what causes auroras. There's a strong belief about what creates the auroras on Earth. However, there's other theories as to what causes it as well. I'll just show you the clip there. So, anyways, thanks for watching, guys. Like, subscribe, comment, and we'll talk to you next time.